And if I give this to you now, you're not going to lose it, right?
Me?
Yeah, you.
Oh.
Okay. Here, you want the folder since you're the only person in here who's the same? You're going to take it in call. Now, this is only part of our quiz for tomorrow. This is the first part, being able to draw the Lewis structures. The next two parts we're learning today. How about now? We got enough time?
Yeah. Yeah.
All right, did you say yeah? I can finish reading that news story later. So, how many electrons did y'all count up for SBI 3?
26.
26. Who's the central atom?
SB.
SB? All right, so SB is in the middle. How many eyes am I drawing around it?
3.
And you said 26 electrons. So, like I told you yesterday, drawing all 26 before you decide. Here, let me change colors. I don't like that. So, drawing all 26 before you try to do anything with a double, triple, or single bond. So, there's 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Those all have 8. So, my 26 have to go there. So, when I draw on all 26, is there any need for a double or triple bond?
No.
So that's what you have. All right, CBr4, is that what I saw? Yeah, CBr4. So how many electrons did I have? 32. All right, who's my central atom? C. How many BRs do I have? 4. All right. And 32 electrons, you say. So grab another color. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 6, 28, 30, 32. All right, once I put all those in, does everybody have 8?
Yeah.
So again, no double or triple bonds. Okay, so the last one was what, H2CO? All right, how many electrons do I have this time? 12. All right, who's the central atom out of H2CO? C. All right, how many O's am I drawing? How many H's am I drawing?
2.
All right, so, and it doesn't matter if you had them in a different order, you have something down here and nothing on the side or the top. All right, you just need 2 H's and an O. All right, so you said I'm drawing 12 electrons. All right, what did we learn about the H's yesterday? They never have what? They only get 2 electrons, which translates into what?
No dots.
No dots, and how many lines?
1.
1. So once you draw your line on the H, those are done. So there's 4 of our 12 taken care of. So 2, 4, 6, 8, 10, 12. Okay, so I've drawn in all 12 electrons. The H's are good, right? They need nothing. They've got their 2. The C has 8. The O has how many? It only has 6. It's got to have how many also? 8. C has 8. O only has 6. So C has to help out the O, right? So how can I have the C help out the O?
Take off the dots and add the dots.
That's right. So these 2 are going to go there and help out the O. So all I'm going to do is move these to right there, and then everybody has their happiness because they all have 8. So I'm going to take those. I'm going to put them right there. So does everybody have the 12 and the 8? All right. So do I still have 12 that y'all added up? 1, 2, 4, 6, 8, 10, 12. I have the 12 that y'all added. H has 2. H has 2. That's what we want. 2, 4, 6, 8 on C. 2, 4, 6, 8 on O. So we have the 8. Questions about how I did that? We good? Can we look at homework? Okay. Now, there are a couple exceptions in the homework that I gave you. One of them is one of the 2 you have to know. Hydrogen is one, and I think I said boron was the other. And so boron is in the homework. Let's find bonding here. There it is. One through 14, there it is. All right, boron will only have 6 electrons. It's your second exception you have to know. Now, this one shouldn't have been hard for you to draw because I drew some the other day where I had more than 4 around the atom. Check those and see if you have them right. If you don't, fix them if you want to.
Wait, so boron will only have 6?
Say what now?
You said boron will only have 6?
Yes. Yes, ma'am.
Can I get that?
Yeah, come here.
Is that for BCl3?
Yeah.
How many electrons did you have?
And we'll do precious too.
Me
While you're
too.
up there about.
You just erased, well, I had 2
Yeah, you probably have, if you drew it and you followed the 8 rule, you probably double bonded.
Yeah.
Take away a double bond, and then you'll have it. It's just an exception. It doesn't form 8 on boron.
What's that, exception for sulfur?
Oh, that's just one that has more than 8.
Okay, oh, yeah. that's what I
Yeah, you
thought.
just draw the 6 borons around it, or bromines around it, and then you're good to go.
Can any element have 1 egg?
Not any element, only certain elements, but if it has like 6, you just draw the 6 around it. Or if it has 5, you just draw the 5 around it. All right, has everybody had a chance to check the first 6?
Yeah.
And Precious and Danielle said you're probably, or I know Danielle is, I doubt Precious will. But I know that since you're probably right, some of these down, I'm just gonna exempt this homework from y'all on count of cases. Okay, you don't have to turn it in. All right, so, everybody got it?
No. I'm writing down the long complicated one. I don't
What's
understand.
the long complicated one?
The BR one, I don't understand.
You just draw sulfur in the middle, and how many bromines does it have?
6.
Draw all 6 around it, and then they do what? So when you add up the electrons, how many electrons did you add up last night? You added them up.
8.
How many?
48.
So you draw S, and you draw 1, 2, 3, 4, 5, 6 bromines around the sulfur, right? And then you say 1, 2, 3, 4, 5, 6. So there's 12 of your 48. Okay? And now we got to keep going to 48. So there's 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. And you keep going until you get to what number? She said 48? I need to stop and count. That should be 48.
Well, the S has like way more than 8 there. So
I know.
That's why I was confused.
The octet rule, which we're going to talk about today, where all of them have 8, is just a nice jumping off point for a first year class. Some elements are going to have more than 8. Okay? This is the joy of being in the honors class. This is called an expanded octet. There are lots of expanded octets I could teach you. I'm only going to teach you 2. Okay? If you have to take it at the university level for your degree program, they may teach you more. I'm only going to teach you 2. Precious, I really need you to put that phone away. Okay? Before I treat y'all like 4th period yesterday. And for the rest of the semester, if I see a phone out, it ventures into my eyesight, or I see it plugged in and charging, it automatically goes to the office. No questions asked. They have completely taken advantage of the charging policy. And so I have lost my graciousness with 4th period. Okay?
Wait, so we can still charge ours in here, right?
Unless you're going to hold it up like Precious is back there.
All right, Precious. I don't know what's going on.
I don't either. Put your phone up. All right. So page 2 of our homework answers.
That was PI.
What do you think it was?
I was trying to find.
PL.
There's no PL on your table.
Exactly.
So that should have told you it was not PL.
Wait.
I was trying to find that too.
Wait.
There's no PL.
I
thought
looked
it
it up
was
on
CI,
Google. I
Not
thought-
CL.
Where do you do the double?
Miss Wall. Miss Wall. You're gonna have to make that L capital or something.
This wall.
That is not.
I thought it was CI.
That's what I'm saying. Okay. Thank you. You have to say for yourself.
Y'all been in here 10 weeks.
You're confusing us. That looks like 4 elements, right?
No.
No.
No. That's phosphorus and iodine. PL does not exist on the periodic table.
I thought it was PL.
For number 7?
If it makes you feel better, people do every year. But there's no PL on the periodic table for future reference.
I knew there wasn't on there. I just thought this worksheet was like old or something.
And you thought I made up an element and left it there for years on end?
Yes.
Okay, dudes. Right.
On number 8, does it matter which one we double bonded? Wait, huh?
And number 8, does it matter which one you double bond?
What if I triple bonded?
You cannot triple bond, but if you double bond NCl instead of NO, that's fine. But you cannot triple bond that.
Why?
It won't work. Tell me, let me see what you
Oh,
have.
wait. I don't know why.
Do you want me to look at it?
No, I fixed it. I just, yeah, I got it.
Anything else?
It doesn't matter, you said it doesn't matter which one we did.
No, if you double bond the NCL instead of the NO, that's fine.
What on the ends?
I looked at, you go to that, yeah, it's high, check over, actually look.
11 something. I'm like, but I want to
Not coming Friday, you sign the petition.
second tomorrow. I have to do this appointment. I kind of don't want to make it before this. So.
What do you think?
No,
about
it's a petition. We do.
Really?
What do you think?
That's the dumbest thing I've ever heard.
I think for the reading the petition.
Positions?
This is not coming to school on Friday.
Not saying-
Because, y'all are trick or treating on Thursday night and it's not fair that y'all have to come to school on Friday.
don't know. Is it a
Wait, what if you
petition
do
or
if you
not?
don't come to on Thursday?
Because like,
It'll make more
Y'all gonna be
sense.
tired on Friday because you were out late trick or treating on Thursday night.
It doesn't make, it makes more sense to have it like Thursday
They
if
did.
you're gonna do
The
it.
day of Halloween.
Yeah, the day
not
of.
day
After.
Yeah, but y'all are in high school and you will be out late trick or treating. The people who give out candy are up to midnight handing out candy to high schoolers, so y'all don't need to be in school on Friday. Yes, ma'am. Huh? Where at?
Like for each double, I keep
So pick one you want me to
It's not
do.
like it's on the
Let's do
paper.
it.
Okay?
First of all, the school board would not, they don't care about what they're talking about.
And they have to get it approved, and Halloween is tomorrow.
Y'all have no hope. Y'all had no hope before. Y'all have no hope now either.
No, for what?
Get the day off. All right, so NOCL. All right, so we can all agree there's one of all of them, right? So you have 5 electrons, 6 electrons, 7 electrons for a grand total of what? Who's the central atom? Who's farthest left on the table out of N, O, and Cl? N. Okay, N is farthest left, so that's why N is in the middle. You can put O or Cl on either side, up, down. You can put it in an L shape. How'd you draw it? I'll draw it the same way you did, Sam. Cl on top and O on which side? Left. All right. So once you do that, all right, we need to put in 18 electrons. So 2, 4, 6, 8. Two, 4, 6, 8, 10, 12, 14, 16, 18. All right, so I drew in all 18. Okay? So first thing I'm going to do is draw in all that I added up. So once I've done that, does everybody have 8? Who doesn't have 8? Okay, so we need to help O. Who is the element directly beside the O? So N has the 8, so N has to help out the O. So we're going to take 2 off the N and put them where? Next to the O in the middle. So we're going to take 2 off of the N. We're going to put them right here in the middle to help out the O. Okay, now if you were the person who had this one only having 6, you were taking 2 off the N and put it on this one and put it in the middle. I just had only 6 on the O. Okay? All right, so last 2. All right, questions about anything on the homework?
Yeah.
All right, so now we're going to talk about geometries.
Do I need a periodic table or anything else?
You might need it to be able to draw Lewis structures eventually today, but probably not right now or immediately. Now, this chart that I just handed you, you cannot use on any quiz or test. I gave it to you to help you take less notes today. You will have to take some, but we will cut down the amount that you have to take to speed things along a little bit. that down there. That's not what I want. That's what I want right there.
No.
All right, for those of you who want titles, let me see here.
On the sheet or on the Wait, what? Is this in our notebook or on the sheet?
On your notebook,
Well, I got it like 3 weeks ago. But each number should do it.
there you go. There's the title.
It's supposed to make it like.
I'm just handing out the sheet because you're gonna need it a little
I
bit.
don't know if it worked.
Pardon the interruption. At this time, we need all seniors, last name A through M, to report to the college fair in the cafeteria. All seniors, last name A through M, to report to the cafeteria for the college fair.
That's where you go and see the reps for the various colleges.
Cool. How cute.
Everybody got it?
Spaghetti.
All right, so valence, shell, electron, pair, repulsion theory.
Did you write all that?
Yes, dear, you need to write all that. I already gave you part of it written out on a piece of paper. All right, we got that?
No.
You only got right a line.
Oh, you're right, the other part too. Okay, I have that on cover. All right, I'll be kind.
You don't have to have the next invested?
Y'all there yet?
You don't do our essays? Oh, and you the progress.
Pardon the interruption. Will the remaining seniors please report to the cafeteria for the college fair? Remaining seniors, please report to the cafeteria for the college fair.
You gonna sing to us over there today?
What happened?
I said, are you singing to us today?
Yeah, you make me laugh too. No, I'm not. I don't know.
Probably not.
Yeah.
All right, so what this says is, in a compound, you have electrons, all right? So these electrons, these lone pairs that we've been drawing on our structures. So if I go back to the screen and I draw a molecule, okay? Here it is. All right, like carbon dioxide. All right. These electrons right here and these electrons right here. All right. We know that they have a negative charge, right? And we know these over here are negative, right? Think about your other science classes that you've taken. What do you know a negative charge does to another negative charge? Do they attract?
Yeah. No.
Well, they do. They repel, okay? These two negative charges repel each other, all right? Now, when I say repel each other, do y'all know what the word repel means? They get away. They push apart, okay? So, in a plane, they push each other as far away from one another as they can get, all right? They don't like each other. So the molecule arranges themselves so they can be as far from one another as humanly possible, okay? Sort of like in a classroom. If two people talk to one another, most teachers try to move them so they're as far from one another as they can be in the room, okay? Now, same concept in the molecule. The electrons don't like each other. We put them at opposite ends of the molecule. They arrange themselves this way naturally in the world. We don't have to do it. They do it themselves. So the geometries that we're getting ready to talk about are how the molecules naturally arrange themselves based on where the electrons are. Okay? Everybody got that? What? You don't understand what I said? You're just writing. Okay. Everybody good? All right, so I think that's what I just said. I don't think you need that. All right, you need this though. So you need under the blue line. Above the blue line, I just told you. We drew something different. All right, so to determine the geometry, we need to know two things. And this is the piece you're going to have to memorize off that chart. All right, you have to know the number of atoms on the central atom. And you have to know the number of lone pairs. Okay, that's the important piece that comes off the chart. The part that shows the example, you're not going to have to memorize the example. But you are going to have to memorize the number of things that comes off the central atom and the number of lone pairs. All right. You caught up with me? Yes? No? All right. So we're going to look at what this chart is in hopes that it makes a little more sense to you and makes it easier for you to learn stuff. Okay? Because you got to know it when you come back tomorrow. It's on the quiz. All right? So the first thing that's in the chart, I think I gave you was like CO2, the one I just drew a second ago. All right? So if this is your example, these electrons on the end right here don't like each other. And so they're trying to get as far from one another as they can get. All right? It looks like this. All right? So the parts that you have to learn are how many atoms are sticking off the central atom. Well, first of all, what's the central atom? C. How many O's are sticking off the central atom? 2. So you got to memorize if you have 2 atoms and how many lone pairs are on the central atom. None. There's lone pairs here. Lone pairs are what again? The dots. So lone pairs are on the O's, but do we care about the O's? No. We only care about the C. So how many lone pairs are on the C? None. So 2 and 0. What geometry do you have? What geometry does this look like? What does it look like in a geometry class?
A line.
Looks like a line. Okay? So its geometry is linear. Now, you do not have to know this for the quiz tomorrow, but you have to know it for the test. All right, since y'all have all had a geometry part of math class, what bond angle is this?
180.
Very good, Trevor. All right, it's 180. You have to know the bond angle is 180, and I probably wrote it on the sheet, but if I didn't
We
add
have to
it.
know the bond angle for the specific thing.
Only for a few of them.
Oh, like
But we have-
CO2. Like we need to know.
No. For linear. Linear has what bond angle?
A line.
A line. So what's the bond angle on a line?
180.
180. Y'all know this from math class. Don't make it out harder than it is over there.
I'm not. I understand that. I'm just trying to figure out what
Yeah.
part I need to memorize. All of it.
You need to memorize for tomorrow just that anything that has 2 and 0 is a line. I'm going to show you how to use this in a minute.
We don't need to know the other way.
What other way?
Like if it's linear, it has to be.
Yes. But for the most part, you're going to be finding the geometries after you draw it. Yes, my dear. The 2? Okay, so you got the central atom of C. How many oxygens are sticking off the C? That's how I got the 2. Okay? Everybody with me on how I got the 2?
We can run up this.
You can write on your notes.
So on the thing, I remember this.
Hold on. What's the thing?
The model, the Lewis structure.
Yes, I got him with you now.
You were talking about how it doesn't matter where you put the O's, but
Right. So let's say that Michaela drew hers like this. You can draw it like that all day long, but you got to know because it has 2 O's and no lone pairs that in all reality it looks like this. Okay? You with me? I thought I knocked it on the floor, but maybe not. I think I did too. I don't know where it went though. Oh, Xavier knows where it went. Thank you for being helpful. I appreciate that. All right, everybody good now? All right, so the next one. The next one has no central atom. So you remember yesterday when we drew chlorine? We had Cl bonded to Cl, and it was just one that was side by side. If you have something that has no central atom, it can't do anything but be what? It's just going to be a linear. It's just going to be a line. Okay? Now, let's say that we have something that is like this. Let's see if I can make that look a little better. All right, it looks like this. All right, looks like this. All right, so if you connect the 3 points, what's the shape? It's a triangle, okay? So it's called triangular, and it lies flat in the plane of the board, so it's called planar because it's flat, okay? It lays flat. All right, now we have 3 triangulars, so you cannot just call it triangular. Now, how many Y's are sticking off, Serenity? All right, so the number of atoms is 3. And how many lone pairs are on my X? 0. So we say 3 and 0. And anything that has 3 atoms and 0 is triangular planar. So let's say you drew something on your homework that had 3 atoms and no lone pairs. You would tell me its geometry is what? A triangular planar. Okay? That's how you decide it's triangular planar. It has 3 atoms and no lone pairs. Okay? So, if we did the opening, okay? If we do the opening, let me get out of this. All right? All right, how many atoms are sticking off C? How many atoms are sticking off C? 3. How many lone pairs are on C? What's the geometry? Triangular planar. Do you see how I got that? There's 1, 2, 3 atoms. How many lone pairs are there? 0 lone pairs. So this is a 3 and a 0. So it's triangular planar. You with me? Now, what if I had like this? Is that triangular planar?
No.
Why is it not triangular planar?
Has lone
It has the lone pair on the central atom. You with me? Allie, you with me?
Yes.
Okay. I don't want to hear you not with me in a minute. All right. So, what if you have and I have no idea what example I used on the paper. It might have been this one. All right,
Yeah.
CCl4. All right. How many atoms on the central atom?
4.
How many lone pairs?
0.
All right, it's tetrahedral. Okay, it's pronounced tetrahedral. All right, now this one is not flat. All right, most people look at this and they're like, oh, it's flat. It's 90 degrees. It's not flat. It looks like this. Okay, is this a flat molecule? All right, its bond angle, and I probably wrote it on the paper, is 109.5 degrees. Okay.
So do all of these only work if there's no lone pairs on the central atom?
I'm doing all the ones that have no lone pairs first. What was this bond angle? I probably wrote it on the paper, but what is it?
109.5.
Nope, I jumped back to triangular planar.
Oh.
It's what? 120. It's a triangle that we divided up, right? It's a circle divided by 3, so we get 120. Whoops, wrong way, stupid. All right, now, did I draw another picture on the paper? Yeah, okay. Now, this one is drawn flat. You might see it drawn spatially on the exam. So if it's drawn spatially, 2 of them are drawn this way. That's flat in the plane of the board. All right, did I label it on the paper to tell you what it looks like or what it is? Or did I just draw what they are?
Just draw it.
Okay, you need to label it.
So I can have 4 lines.
All right. So this is in front. This is behind. Now, the in front can be in front of the board, in front of the molecule, in front of whatever. Behind is behind the board, behind the molecule, behind whatever. So, if this is my 2 that are flat, all right, when I stick this one in, see how it sticks out? That's the one that's darkened in, so it's in front of the board. And if I stick this one in, all right, it's going to be sticking out the back. I can't put these 2 again that my fingers are on that are flat. All right, this one is sticking out behind the board. All right, so it's going to take up a 360-degree model. All right, is everybody with me on that so far? Now, the next 2 are the expanded octets. You're going to label them on your paper as
Wait,
expanded.
but how did you get that degree? The 1 and 9.5.
I have no idea how they did it. I don't work it.
That's
That's just a,
memorize.
yep. And they're the only ones you have to know. I may have written the other 2 on there, but I won't make y'all know those. All right, so,
We
These-
just have to know 180, 120, and 1 and 9.5.
all right, so this would be, let's see if I can draw it right. All right, so what's that shape supposed to be so far? What am I trying to illustrate?
The triangle?
So, see the black and white line so far? That's what I drew so far, okay? Oops, that's a little crooked. All right, and then they all have 6 dots. All right, so how many atoms do I have?
5.
And how many lone pairs?
None.
All right, so the Y's that I have here that are in the black and white, if I connect them, I have what shape? A triangle, so triangular. All right, and if I have Xavier help me here. Pretend you found a white, hold your hand up there. Just hold it up. You don't have to hold it so it doesn't fall. All right, if I connect it, what shape have I made? Pyramid. And if I do this, I have what shape? An upside down pyramid. How many pyramids do I have? 2. All right, so, thank you, dear. So in math class, bi means what? 2. So bipyramidal. Okay, because you have 2 pyramids. So triangular, because you have a triangle. Bi meaning 2, and then 2 pyramids. Does that make sense? Okay. So the last one that has no lone pairs has an X in the middle. Let's say a Y. Whoops, I need a line. A Y, a Y, a Y, a Y, and a Y. They all have 6 dots. Okay? It looks like this. Now, if you look at it like this, I'm going to use executive again. All right? If you could put a piece of paper here and a piece of paper here, it would dissect it or bisect it into 1, 2, 3, 4 quadrants on top, and 1, 2, 3, 4 quadrants on the bottom. So you have 4 quadrants and 4 quadrants, which would give you a total of how many quadrants? 8. It's 8 quadrants. Okay, thank you. So the name for this is octahedral because it has 8 quadrants. All right. It only has how many actual atoms sticking off though? 6 and 0 lone pairs. Okay. So it's about the quadrants, not about the atoms. Does that make sense? Yes or no? Okay. Now, the last 3 geometries you have to know have to do with the lone pairs. So we're going to use X. Let's use water. All right. In the top one, what can you tell me about the number of atoms that are hanging off? How many X's or Y's, sorry, Y's are hanging off the X? And how many lone pairs? All right. How many H's are hanging off water? How many lone pairs are hanging off? All right. Now, I drew this 2 different ways because I think it was it Michaela a minute ago who asked me about the lone pairs and the H's? All right. And how I drew it. So this time I drew it with the bent shape, and this time I drew it in a straight line. All right. Does it matter whether I drew it this way or whether I drew it in a straight line? No, because they both have 2 H's. They both have 2 lone pairs, right? Now, what's the shape of this? The shape of this is this. All right? These lone pairs and these lone pairs hate each other. So they bend those H's down sort of like this. So the shape is this, okay? So it was a line, and we did what to the line? Bent it. So the shape is bent, okay? The shape here is bent. Do you have to specify which bent it is? No, it's just bent, okay? So what's the difference between something being linear and something being bent?
Lone pairs.
The lone pairs, okay? If it has lone pairs, it's bent. If it has no lone pairs, it's linear. Everybody with us? All right, last geometry you have to know. All right, and we actually already did this one. So if you have an X with a Y, and a Y, and it has lone pairs right there, all right, those lone pairs make it triangular pyramidal. So the parts that you guys have to memorize are the central atoms and the lone pairs. So when you come in tomorrow and I say to Allie, what's the geometry that goes with 2 and 2? She has to be able to say to me, it's what? Yes. Okay. Or if I say, what's the geometry with 2 and 0? She has to be able to say it's linear. Okay. So when she draws the Lewis structure tomorrow on the quiz, like the opening, and she drew CBR4, and she goes, oh, there's 4 CLs, and there's no lone pairs, you can say it's what? Tetrahedral. Okay? That's what you have to be able to do with the geometry. Does that make sense?
Yes.
All right. You got your homework from last night?
Yes.
All right. You drew 14 structures. I want you to take those 14 structures, find their geometries, using your sheet, given you don't know the geometries yet. And then we're going to figure out how to define polarity. Ugh. Polarity's not hard. There's less memorizing with polarity. That's just conceptual.
Can we write the geometries on the second sheet?
Sure, I don't care how you do it.
What are they?
So you're taking this, and you're figuring out which one of these geometries it is, based on what we just did. Does it have a central line on I-2? So it's automatically what? Yep.
Number 2, HBR, that happens to be out.
You gotta have how many atoms to have a central line?
3.
Gotta have 3. There's no 3 atoms that's automatically linear.
Can you put the answers up there?
What answers?
The blue stick.
I can't know if it's the thing. I don't know.
The thing. So like the only thing that for this we're writing is like linear and like the names.
So what now?
Like we're just writing like linear, like all the names.
Yeah.
Thank you. Lines aren't one pair either, right?
No, lines are not lone pairs. They have to be actual dots to be lone pairs. All right, questions? We're ready to go over it? Any more time? Where are we at?
More time.
Okay.
My job pretty fix on the board. As well.
And you do what?
My job pretty fix on the board.
No.
Oh, they said. You got a nice little pumpkin.
All right. Are we ready now?
Yeah.
Okay. Everybody else other than Allie answering for everybody else, the rest of us feel.
Yeah.
Yeah, Serenity? Okay. Yeah, how about this side of the room?
Yeah.
Okay. All right, so if we go to number 1, what do we pick there? Same. Linear. What do we pick for number 2? Princess. What? Linear is good. Number 3, Alana. Triangular planar is good. Number 4, Zyra. Triangular planar is good. Number 5, Precious. Bent is good. Number 6, Serenity. Octahedral is good. Number 7, Allie.
Triangular pyramidal.
Good. Number 8, Daniela. What? Yes. Number 9, how about Michaela? Yes. How about number 10 for Jocelyn? Good. How about number 10 for Xavier now that he's back?
You number 11?
Oh, 11.
Well, you should have kept that 10 and then all of us could have.
Triangle.
Triangular who?
Hey, Zay.
No. What you got right there?
Oh, there.
Yeah, see that lone pair right there? So it can't be planar if it's got a lone pair. So triangular what if it's got a lone pair?
Triangle. Up here, yeah.
Not bipyramidal. That would have 5.
Pyramid.
Triangular pyramidal. So you got 3 in that one lone pair. It becomes triangular pyramidal. You see the difference? It would be planar if it's got 3 and no lone pairs.
Oh.
Okay, that would be 3 and 0. But because you got 3 and 1 lone pair, it's triangular pyramidal. See the difference? Okay. So number 12. How about Gerardo? Bent is good. All right. Number 13, Victor.
Tetrahedral.
Yes, tetrahedral is correct. And 14, how about you, Trevor? Yes. We good? All right. Let's talk polarity. Yes. Know how excited you are about that.
Thrilled.
I know. I only do it because I know how much you like it. There's your title. For those of you who need titles.
You did the tablet the time around? Yeah, I think in minutes or something.
Did I, do it right?
No. Yeah. Cause she keeps separating the law, but she said to 3, but they're supposed to be that way. Right. Yeah, that's what she does. She doesn't touch it.
The context thesis explained. And then the other one was different because A was thesis and B was content.
We only had to do that, like, we didn't have anything else.
Yeah, that was.
All right, we got it? All right. So, this is where we have to talk about the difference between bonds and molecules. Okay? So, in some ways, we have to look at vocabulary here. So, we're going to do a little bit of review, just a little bit. Okay? So, bonds, okay? Bonds can either be ionic, polar covalent, or non-polar covalent. So this trips people up on the test. You have to pay attention to what they're asking for in the question. If it says bonds, what bond type? Okay, you're going to use the what to determine the bond type.
The line.
The line, okay? Just like you did on the quiz yesterday. You're going to use the 4.0 to the 1.7 to the 0.3 to the 0. And we knew that was ionic, polar covalent, non-polar covalent, okay?
This is what science is volume.
What kind of volume?
Loud volume.
Oh, I'm just loud.
But it's not just you, it's like all of them. Except for Miss Woodman, she's softer. Well, sometimes.
I don't know. I've always been loud.
Yes.
Maybe I should just try talking like this and see how it
No,
goes.
no,
So try that for
no.
2 days or a week. So for CCL, I save my voice if I do that.
No. You sound like you're trying to lure children. Like,
What? I should just get some candy in the van.
I'm scared.
I'm definitely calling this in here.
So what?
If you talk like that, I would definitely call it.
The
The only thing that keeps you like awake is when you yell.
See, I don't think I'm yelling.
Yeah, you
That statement was.
start here and then you get really loud. And it's really.
There was this man who asked me like before I was looking scared because I wasn't trying to get kidnapped like all day. And I kept saying this way, and he kept saying right, and I was like this way, and he kept saying. So I go up to the top of the book and I said to the left. He's like, "Are you sure?" I was like, "Yeah." And then I don't know, maybe he was going to pay his bail or something.
I'll never forget one time it snowed and I was in the Target parking lot with my mom and it was like really icy and like there was big amounts of snow and like my mom did not remember where she parked and this guy was like, "Oh, I'll help you find where you parked. Why don't your daughter just sit in my car and I'll help you find where you parked?" Luckily my mom was like, "No, it's okay." Like
Luckily?
yeah,
Why
because
do you
like
think that would work?
looking back at it, like I really could not be here today if my mom would be like, "Yeah, just take her to your
Why would
car."
she let you? But
Because
Oh
me and my
yeah,
mom
let me
were
take your
previously-
daughter while we go look for you.
Wow.
that's hard. My mom did it.
Why would you offer to put me in your car?
Well, we're thankful you're here. All right. So I won't speak quietly since y'all think it's creepy.
Thank
All right. So CCL4. How do we decide the bond type?
The
The periodic table with the numbers, electronegativity.
with the electronegativities. So we look up chlorine, and chlorine is 3.0, and I think carbon's 2.5, and you get 0.5, which tells us what?
It is
Polar
polar
covalent.
covalent.
Polar covalent. Okay? Now, let's consider, and this is supposed to be a subscript, it's supposed to be CCl4, it's just a typo. All right, now let's consider the entire molecule. Okay? So, now we're going to consider the molecule. All right, so that's what you have to look for in the question. If I use the word molecule, I'm not talking about a singular bond. We're going to look at all the bonds. All right? What would happen to polarity if we consider all the bonds? Okay? Would it still be polar covalent if we consider all the bonds?
Are you talking about like multiplying 4 by the?
Nope. We're going to have to look at all 4 bonds in the Lewis structure. All right, so in order for a molecule to be nonpolar, there are lots of ways for it to be polar. All right, so it's easier to talk about the requirements to be nonpolar. All right, so there's 2 requirements to be nonpolar. All right, and you have to meet both. If you don't meet both, you're automatically what? You're automatically polar. Okay? Everybody understand that? You have to meet both requirements to be non-polar. If you're not, I was going to say polar for a minute, I had to fix myself. If you're not, you will be polar. And I'm not talking about a polar bear either, or being cold.
Every
That's
time you
not-
say
yeah.
polar, I see a polar bear.
I think of the little Coke cans with the polar bear on it.
Right. Skin of polar bear.
All right, we caught up? All right, so what is the first requirement to be non-polar? All right, the first requirement is all the dipoles are equal. Now, some of y'all are going to be like, I don't know what a dipole is. Yeah, you do. All right, y'all been working with them for days. A dipole is the difference in the electronegativity. Y'all know when you subtract all those numbers you got yesterday on the quiz? That was a dipole. All right, so if all the dipoles are the same, all the difference in electronegativities are the same, then the dipoles are equal. So when you were subtracting yesterday and you got 1 point something, 0.04, 0.1, those were dipoles. Okay? So if they're all the same in the molecule, that's one of the requirements to be non-polar.
Wait, where's dipoles again?
The difference in electronegativities.
Oh.
Okay? The electronegativity difference is the dipole. And number 2, all the dipoles have to pull in equal and opposite directions. Well, how do you know if they pull in equal and opposite directions? You know this because there are no lone pairs. Now, where are the lone pairs going to be important?
Central.
That's right, on the central atom. Okay? If there's no lone pairs on the central atom, then they're pulling in equal and opposite directions because the bond angles are equal. All right, we got it? Everybody got the steps? All right, so let's talk about some examples. All right, CCl4 is the one we were doing, right? So I'm just going to draw it up here. Yep. All right. We're trying to figure out the molecule polarity. Okay? So if we want to figure out the molecule polarity, we have to check two things. If the dipoles are equal, and number two, I don't want to phrase this, so I'll have to write that whole thing out.
Did you mean to draw a line on the CO?
Yeah, I did. Thank you. I just forgot it.
So I was confused.
Okay? And I'm going to write opposite directions. All right. That's as short as I can figure out how to make it. So we don't have to write out those whole steps. All right. So to figure out if the molecule is polar or nonpolar, in order to be nonpolar, we have to meet both requirements. Okay? So how do we know if the dipoles are equal? All right. In order to have the dipoles equal, they have to have the same electronegativity difference. Okay. Now, we can subtract every single time we do this if you want. Okay. I don't like to do that. It's a lot of extra work. All right. Basically, they have to have the same two elements on every bond. If they have the same two elements on every bond, what do you know is going to happen when you subtract? Will you get the same number? Yes. Now, if you don't believe me, pull out your electronegativity tables. Just pull out your electronegativity tables. Got your charts? All right, look up C. Tell me carbon's electronegativity. 2.5. What is chlorine's electronegativity? 3.0. What do you get when you subtract that? The dipole is 0.5. What's the dipole going to be when you subtract 2.5 and 3.0? This is 3.0, right? So 2.5 minus 3.0, what you getting here? What you getting here? What you getting here? What can you tell me about all four of those dipoles? They're equal. Do we need to do that on every single molecule? No. Because what can you tell me about all four of these bonds? Do they have the same two elements or do they have different elements?
Same two.
As long as they have the same two elements, what can you tell me about the dipoles? They're always equal. We meet rule 1. Now, in order to figure out if they go in opposite directions, okay? As long as they have no lone pairs on the central atom, they go in equal and opposite directions. Okay? Do we have any lone pairs on the C? What kind of molecule is it? It's nonpolar. Now, if we go back to this, what do we say about the bond type? The bond type was what? It was polar covalent. What's the molecule type? Sometimes the bond and the molecule are the same. sometimes the molecule and the bond are different. So on the test, can you subtract the electronegativities and get the molecule right? Not necessarily. So you've got to pay attention to the question and know if they ask bond or if they ask molecule. Okay? So let's do water.
Wait, so is that one not?
That was nonpolar.
It was?
Yeah. All the dipoles are equal. They're all carbon-chlorine bonds.
And then
There's no lone pairs.
oh, okay.
We meet both rules. It's nonpolar.
Is this gonna be the question now?
Yep. It's the third column. How did I write that a second ago? So I do it the same way, opposite direction. Here, I'm even going to shorten it. No lone pairs. Make it easier. Are the dipoles equal and no lone pairs? Make it easier.
It's polar.
All right. So when you look at this, okay, what can you tell me about those bonds? Are they between the same two elements on both bonds?
Yeah.
Yes. So the dipoles are equal because these are between the same elements. So we meet number one. They're both O and H. When I subtract, I'm going to get the same number on both bonds. Do I have no lone pairs? What does that tell us?
It's polar.
Are you with me? Okay. What if I have one? What if you have this?
It doesn't meet the first one.
It doesn't meet the first one. Why not, Allie?
Because it's not the same element, like between all the ones.
That's right. It's not the same elements. How can you tell it's not the same elements? People are looking up here. Some are writing. Some of them are just staring at me. It could be they're bored. All right. How do we know it's not all the same elements? Tell me how you knew. The BR. Okay. When you look up here, 3 of the bonds are CCl and 1 of the bonds is CBr. Okay. As soon as you can tell 3 are carbon and chlorine and 1 is CBr, this one automatically defaults. You know what? It's polar. Are you with me? Yeah? All right. Let me look at Trevor's chart for just a second. I think I know what I want to do. All right. Yeah. Let's talk about 2 exceptions. There's always exceptions. What if you have one that has no central atom? What do you do if you have something that's just HCl? How do you decide? What do you do if it's just something like that that has no central atom? What do you do? Zyra, what would you do? This was on the quiz tomorrow, and you were staring at it, and you were like, what do I do here, Ms. Wall? You what? Which chart? And do what with it? Exactly. And then what would you do with it once you subtracted it? Using what numbers? I'm just asking which chart. Give me the numbers on the chart. Very good. All right. So when you have a single bond, okay, and this is all this is, all right? Okay, just single bond. You got nothing else. One bond. All right, and I don't care if it's a double or triple bond. Okay, up here at the top, I'll put double / triple. Okay, but one bond. All right, you're going to subtract the electronegativities and use your 4 to 1.7 to 0.3 to 0 and decide if it's polar or non-polar covalent. Okay, because you only have one bond, it works just like what you did yesterday on the quiz. Okay, Zyra was exactly right. But because there's no central atom, it works like yesterday. You can't use the two rules because there's no central atom. Okay, that one most people do right. It's the next one that is the kink. And I very rarely, if ever, give this next one, but you might see it. So I want to talk about it ever so briefly. You will see it in the homework. All right, everybody got it? Let me label exception again. All right. What would most of you tell me that is? Just a quick glance.
Polar,
Why would you tell me it's polar?
because it has the two dots. So
Yep. Most people would look at this and they would automatically say polar because of those two dots. Okay? But it's not polar. This is non-polar. All right, so why is it non-polar? Got your electronegativity sheets handy? Tell me what the electronegativity of P is. 2.1. What's the electronegativity of H? What do you get when you say 2.1 minus 2.1? All right, in order to have a polar molecule, you have to have what when you subtract? A number. It has to be something besides 0. Okay? If the numbers cancel, it is a non-polar molecule. Okay? You must get a dipole of at least 0.1 to be polar. And if you get 0, it's a non-polar molecule. Okay, it doesn't happen very often. P and H will do it, N and maybe Cl. Yeah, nitrogen and chlorine will do it. There's very few combinations that will do it, but every now and then one will. It pops up. Okay, so just be aware that that can happen. All right, you think we can do the homework? Figure out who's polar, who's non-polar?
Yeah.
All right, so find your homework.
Oh.
I'll pull it up for Princess here. Yeah, Precious. I was going to say who was absent yesterday. It's Princess. Precious who was absent. Princess was here. All right.
So, what did you say on the quiz that we need, like?
The first column is draw the Lewis structure. The second column is tell me the geometry. The third column is tell me polar or non-polar.
Okay, the only thing I'm confused about is when you send the notes, like the difference in the molecule and the bond. Like,
I'm not going to ask you bond type tomorrow. I will on the homework tonight. The homework and the quiz are very similar. Except the first column on the homework is tell me bond type. I'm not going to ask you that tomorrow because I did that yesterday on the quiz.
so how is that different from the
For
bond
bond type, you just subtract.
This you actually have to look at, like.
You have to look at the bonds and you have to look at whether you have lone pairs.
Okay.
Yes.
And this one you won't have like metallic or ionic. It'll just be.
Correct. Correct. You know everything on the quiz tomorrow is covalent. So you're just telling me polar or non-polar.
So if there's no central atom, it's like,
There's no central atom, then what does Ira tell us to do?
subtract.
Subtract the electronegativities and decide if it's polar or non-polar that way. Yeah.
What is ionic representation? Are we doing that today?
Probably not giving us 948. I'm doing tomorrow. They work like balanced equations with electrons. You have to show where the electrons work, where they go after they're transferred from one atom to the next. They're not bad, but they're not Lewis structures. And then we have to talk properties and what happens then. And then we do van der Waals forces. And then we'll be ready to test. I'm going to check out the multiple choice and see if there's anything I can maybe eliminate today to shorten the test for poor Allie and who was the other person who complained about the test being too long? Somebody in second. I think it was Marilyn. I don't know if I can shorten it. Through response, I can. But I'll look and see if I can trim up any of the multiple choice.
So the pH 3 is like a specific exception.
Yes, another one I could think of is like NCl3 because nitrogen and chlorine have the same electronegativity. All right, we ready?
Yes.
All right, so if we look at number 1, what do we do? What are we doing 1?
I just thought they were both the same. That's a non-polar.
It is nonpolar because if they're both the same and you subtract, I think that one's what, 2.5 and 2.5? So you get 0. So nonpolar. HBr, 2.1 minus 2 point something, and it should be polar. All right, 3, nonpolar. 4, nonpolar. 5, polar. 6, nonpolar. 7, polar. 8, polar. 9. Are they all the same? No, you got 3.
I'm done. I'm sorry.
You got 3 bonds that are chlorine and 1 that's bromine. That's why it's polar. All right, 10, polar. 11, polar. 12, polar. 13, nonpolar. 14, nonpolar. How do we feel about it?
Good.
Okay, let's talk homework. Alright. Now, on the homework, you're doing the charts. Now, before I hand it out, pay attention. In the first column, it says bond type. What are you doing for bond type?
The ionic.
Yeah, you're subtracting, okay? The second column says Lewis structure / geometry. So you're drawing the Lewis structure, you're determining the geometry. And then the last column says molecule type, so you're doing what?
The non-polar polar.
The non-polar polar using those two rules. When you flip it over, you're stopping at the chart. Don't do this part B short answer crap. Okay, you're only doing the charts. Now, the only part that's not on the quiz tomorrow is bond type. Okay, you have to do the geometry, you have to do the Lewis structure, you have to do. Give one up. Nobody behind you today. You watch the rest of the video here and caught
So
up.
basically, you just add up like you need, and you get an odd number.
You have one, right?
Like a minus one, you really like the plus one, so you add it and one, and then you subtract it. Anytime it's like you see a negative one, you subtract the structure. But that's the only difference.
This one I can. Minimize and keep.
Come along.
What we got?
I'm gonna say hello.
Hello, Michaela.
Thank you.
Okay, I managed to stay awake today.
I don't like when I say thank you and people don't say it. Like the SRO, whatever his name is, officer held the door open. So like two people and I said hello. I mean not hello, I said thank you and he did not say thank you.
Most uncomfortable thing is when they're like, like, thank you. I hate that.
I just felt like I did not get to choose that one because everybody else walked through without saying thank you and I said thank you at least like
You know what, I'm just trying to make somebody's day out here, but I can't even
Right.
do it.
soothing.
Y'all stay in a chair till the bell rings.
No, shut up.
And they didn't let me see it because I was 16. I was like, boy, so wet. Why so quiet? He's 17. He's 17. I was in the
Look who's back.
But I felt too easy again for the stupid knee. I hurt it again.
I don't know what to tell you, dude.
No, but I know. And I already know what I'm doing for the quiz, right? I know what I'm doing. Right? Isn't it the same stuff? Because I heard we got to the quiz yesterday, and I could study tomorrow.
Okay.
For it.
Oh, you want
So, and I know what I'm doing for that, right?
Oh,
Because it's what we've been doing. It's been like the still.
subtracts and electronegativity is that?
Yeah.
Okay. All right.
I'm gonna tell you.
Okay. Sounds great.
And then tomorrow, what have I missed? Wait, didn't y'all take a test?
Lewis structures.
Y'all haven't taken a test, right?